So we come to our last session. Last but not least, Erik Bossong, and he's a senior manager for research and development at Gropius. And before he worked in the management field of non-profit research institutions and other fields of technology, fabrication, and digitalization. Sorry. And a very important thing is you are a carpenter too. You have a carpenter degree. That's very good, I think, very important. And yeah, you studied in Rosenheim, and you are also a member of the AIF FTK Innovationsnet in Baden-Württemberg and also at the Leichtbauzentrum Baden-Württemberg LBZ-BW. So yeah, thanks for coming, and now it's your turn to give the last lecture for us. Thank you.
Yeah, it's a little bit more down to earth what I'm going to show you, but I think it's fitting quite nicely with the topics you already heard, and so I'm going to give you some insights on what we do at Gropius in that in that field of interdomain digitization. So. As you have heard in the ACU or AEC sector, the digitization level is very low. So I've been away from that line of work for 20 years, and when I came back 2 years ago to Gropius, I found out that not many things had changed in those 20 years, which was really quite a horrifying idea. So. In the AEC sector, of course you have a lot of software, and of course you have a lot of engineering and stuff, but you usually do not have them all in one company. And this is where Gropius comes in, because we are actually describing ourselves not as a construction company, but as a tech company with an adaptation to construction. So now I'm going to show you some idea of what that means for us. Because if you see our mission, I highlighted those two things: continuously evolving products, and the other one is conserving or saving the resources of our planet. And I think this is very important because we have established a product view on our buildings. So we are building large, constructing, developing and building large timber buildings, like for 4 and 5 stories for residential housing. But we do not see them as projects, like say we build one house here, build one house there, and so on, but we see them as a product. So the idea behind that product idea is that we can evolve the product and we can scale the product up. And now, of course, you might say this is quite difficult to see a building as a product, and of course you're right. I mean, a building is always unique as it sits in its own space with a different ground, on a different surroundings or whatever, but still I'm going to show you that it's possible to use the product view, and I will show you why it is so important for us. But first thing, I want to show you that we have a very holistic view, and this is very important if you look at the digitization, because when we start thinking about buildings, then of course the first thing is that we have a plot of land on which we build the building on. So, and we want to optimize that plot because, I mean, land is scarce, and so we need to be very efficient on using it. The second is that we see the need for end-to-end integration, which we can only do by digitization. So we want to have a process that starts with the plot and ends with taking down the building after it's been used for 50, 70, maybe 100 years, and then still be able to do everything the way we know, because we know about everything that happened in that building and the time that it stood on the plot. The third idea behind the end-to-end integration is the smart factory, the smart production, automation. We have heard a lot about flexible automation, for example, and of course with the ICD, this is quite a common sense understanding. But if you look at the way that timber housing has been built so far, it's been quite, well, it's not flexible, it's quite strict the way it works. And if you look at the car manufacturing, then you have a lot of automation, but you have that also very strict. So the idea of having a flexible and easy to manipulate production is quite inherent for us. Yeah, and then of course the integrated on-site assembly. I mean, if you take those pre-assembled parts that you have in our production, put them on a building site, then you need to be sure that everything works and it works in time and in budget. And this is, of course, a major point. Which brings us to the finished building. The finished building itself is equipped with a building operating system, and that is one of our biggest pillars that we have in the company, because we have all those software engineers ourselves that develop that software, and that software itself is another product that we have. So even if we see our buildings as a product, we also sell that software as a product itself, and we use it for our own buildings. And we come back to that software later on. And then, last but not least, we talk about end-to-end integration, because we have we call it a deep sustainability approach, because everything we do in that company has already been assessed by our sustainability team. So it's not like we build a building and then afterwards we calculate what the sustainability effects would be, but everything that we do, we will first run by the sustainability team and their processes, and then we will put it into the building process. So I now want to give you an idea about the idea of end-to-end integration. If you look at the manufacturing side, then you have those very precise robots. We can build and pre-assemble our walls like with the tolerance of 0.5 millimeter. It's very precise. And then you take them to the building site and you try to erect the building and it doesn't work. That's what happened with our pilot building. So it's a 9-story building, and we had huge problems because the floor plate of the building, which had been done by a local company, was just that they had a tolerance of 5 centimeters. So we had problems putting our walls on that floor plate. And so of course, if we would have known that whilst the floor plate was being made, then we could have worked on that problem before. So this all leads us to the idea that we need to know about everything that happens in the process. So to sum that end-to-end digital integration up, I would say that we get a huge reliability into the processes because we have parameterization and digital planning. So of course all the tools that you know, like Revit, Grasshopper and so on, that's all been used by us as well, but it's integrated in the whole process. Then we have a digital twin that we use in the way that it's already known. So it's a digital twin that is just equipped with a lot of information about the building itself. So we know where every screw is being put, and we know what insulation material is in what wall and so on. So this is all relevant data if we want to think about like managing the building or refurbishing the building or taking it down after it's been used. And this is of course a main core function. But of course by digitalizing we also have a higher value creation because we can be more efficient in the production, for example. So this gives us the chance to have a higher output. We also have a better standing in the legal compliance, because having all those data in real time in our system, we can always say what we have done, what has been done at what time, what cost, and so on. So this is really important. And last but not least, the end-to-end integration is, as I said, been shown in the building operating system. So, and I'm going to give you some small example. This is our first pilot. This is a building in Koblenz. It's 9 stories. It's a timber hybrid system. And if you move in that building as a resident, then you can downsize your carbon footprint by 13% just by moving into that building, because it's so energy efficient that you are actually doing something good for your own carbon footprint, of course. But how has this been achieved? So we have, if you look at the carbon in kilogram per square meter and year, then we have a reference building by the DGNB that's like 9.4, I think, kilograms, and in that building we have 8.4, which is not so much less, but we have a very good efficiency in operating the building. As I said, we have that building operating system, so we can log all data, we can see the energy consumption, and we can optimize all the time. So by this, we can really downsize the level of carbon footprint. And if we look at the system that we are developing at the moment, so this has been the pilot, and now we're moving on to the next system, we're already going down from 8.4 to 6.5 kilograms. And with the future system that we are heading for, we want to have 5.5. And this is embodied carbon, so this is what we have in the building itself while it's being constructed. As I said, we have that deep sustainability approach, and that means that we have a design for sustainability. As I said, we run all processes that we do by the sustainability team, and they apply all the ESG and DGNB criteria, the EU taxonomy, which helps us a lot because the EU taxonomy is actually what we need to promote our buildings. And by doing all that, we get we're heading for a climate positive operation of the building. So the idea is that of course, we cannot build a building without any carbon inside the material, because as soon as you use any material, of course, there will be carbon embodied, but we can lessen the results of that carbon by maintaining a life cycle assessment that is climate positive. So we use like solar energy, we use a very efficient insulation, we use that building operating system to find faults in the system and to run a very efficient building housing technique and all that. And in that way, as if we calculate the usual 50 years, then we can get our buildings climate positive. And with that approach, we can also compensate buildings that are older in the neighborhood, for example. So this is very important in our mission statement. Now I want to give you an idea about that title of my presentation, the information model-driven approach. As I've been talking about the embodied carbon and the operational carbon, we have had the idea because there has been a call for tenders by the Ministry of Environment and the Federal Ministry of Environment in Germany. They wanted to have digital applications to increase circular economy business ideas. And we were thinking about that, and so we have had that idea of an so-called eco-twin, which has the approach to develop new conceptual models for data, so as to make sustainability a concept that you do not only use like with material and physical stuff, but you also use it with data. So we think that there is, at the moment, not enough idea of using data to establish sustainability in processes. And so we developed a conceptual model to have circular applications by using the data that we have in our digital twin, for example. in the data graphs that we use, so that we can run all the system in real time with loops and can find optimization potential and find faults in the system and so on. So we can always use the data that we have in existing buildings to optimize the next building system. So that's why we say we can evolve the buildings. And if we have a look at that further, this is a very rough idea of the conceptual model. On the left hand, you can see the real time, not the real time, the real world, the physical side of things, and then in the middle you can see the whole ontology stuff, which is quite magic to me, but my colleagues know what they do, so they know the way of harmonizing the languages between the different domains. So the domains that you see on the left is like everything that you know from buildings. And after having harmonized all those data streams from the different domains, you have that it looks quite small, but it should actually be a huge data lake, and you can use different approaches and different views, perspectives on that data lake for every need that you have. So for example, the eco-twin would just be one perspective that you can do out of that data lake. But you could also have say, okay, you want to have a cost twin, or you want to have like a waste twin, or you want to have a logistics twin, whatever. So this is all things that we will need in the future, and so that's why we see a huge impact in developing this. I don't know if you get the idea of the circulating data flows, but that would be the idea behind that slide. The first problem that we encountered when we thought about the eco-twin was that, of course, this is really important as residential buildings are a big emitter of carbon, but the eco-twin itself has the real problem that you have difficulties aligning the calculations. So if you look at sustainability calculations, if you look the way that houses are being calculated in their carbon footprint, it's like there are no two ways of calculating the stuff getting to the same result. So if you take two people with the same idea behind it, they still get different results. So it's one of the major expectations in that project to align all the calculations so that we can compare all the buildings that we have and compare them with the referential buildings, and really can believe in our carbon or sustainability calculations. So the first step in the project is to align all those calculations, which is already on its way. And the second step will then be the optimization of the embodied carbon while further optimizing the operational carbon. The operational carbon is a little bit easier to calculate in our perspective, but the embodied carbon is quite difficult to get. But we're setting up all this data with collecting data about the materials and developing our own materials and thinking about new insulation materials and stuff like that. So we of course have the need, as I showed you, those 5.5 kilograms for the embodied carbon. So we still have the need to really lower the embodied carbon in our buildings. So, and if we look at this embodied carbon and the operational carbon, then of course the data flows of the eco-twin give us the possibility to optimize as far as we can go. And so we are quite positive that we can reach the goal of the climate positive buildings. And as I want to give you an idea of how the numbers look at the moment, already with our first building, our pilot building, then this is what you can see. So this is real data. If you look at the left side, you can see the embodied carbon. On the right side, you can see the operational carbon, and you can see the reference building from the DGNB. You can see the building design that we have put up in our first pilot. And you can see the stage 1 and stage 2, which is the now being processed development, and the one that we want to focus on afterwards. And so you can see the reference building is 9.4 kilogram. Then we went down to 8.4 with our first building. We're moving to 6.5 with our current system and heading for 5.5 with the future evolvement. And the operational carbon is at this point much more interesting, because the reference building is by 20.3, but we're moving with level 2. We're moving below 0, so we're actually like burning carbon, if you want to say so. So this is very important, because then we get here, if you say this, the savings against the reference building. Reference building, you can see with the draft, it's 6.3, and then we're going to 30.7 kilograms per square meter and year. And my colleague from sustainability has done some scenarios only with the prototype, the pilot building. You can already see, if we just, as we're a company, we're of course in need of earning money, so we're calculating with the scaling of our building product that we can sell. And so his first scenario is looking at a growth rate of, I think it's just like building 44,000 square meters per year. And as we're accumulating those 44,000 square meters year per year over 50 years, always for each building, then we can see that the climate impact is linear, but it's of course getting quite high. And this is, as I said, only the building that we have already built. So, and if you would now say, okay, timber building is really going up, so everybody's buying that stuff, then you could say, well, it's going up by 10% per year, with the growth rate of 10% per year. And then you're already moving in a direction where it's really getting large numbers of establishing a very, very good positive carbon footprint. But we could also even go higher with 30% per year. I mean, if you look at what our federal administration wants to build per year in Germany, then it might be possible to sell houses at that rate. What I want to show you is just that the interesting information is that as a house is of course being run for 50 years or 70 years or maybe even more. Being a carpenter, we know that a lot of houses stand for hundreds of years, maybe not in Stuttgart, but in the rest of Germany. And so you can see that it really has a huge impact what you can do there with the carbon footprint. And as we have the possibility to turn on all screws by the so-called eco-twin and all the data that we collect, we are quite certain that we can have a huge impact, and we hope that this will be of a very high value for investors and also for other companies using our building operating system, for example. So I don't know, maybe it's a little bit much in a short time, but I hope that you had the chance to get the idea of what we're doing with this cyclic aspects. Okay, thank you, and if you have any questions, I'm happy. So.
So when your company builds have a building, then you can get the data from that building to improve your next building design. And so I imagine that if every country starts doing the same, then they are all going to the information from the buildings, unless the one company builds some building and the other company operates the building. Yes. But at some point, I imagine that some information could be shared from between different companies that are building buildings, or some information is shared with some research group at the German federal level or something like this to improve some practice in buildings in general.
So sorry, there was some. No, just if you could just repeat the last question.
Yeah. So my question is, how this information of buildings could be shared between different participants.
Okay. So do you think in kind of data security or?
In any case, because you are producing a lot of data that is valuable for the buildings, and then you are learning from that data.
Yeah.
And maybe all the building environment have to learn somewhere from the building.
Yeah, we of course we definitely have the idea of sharing that information in kind of also a product approach. So if, for example, if we sell our building operating system, we have already sold some of that, but if we sell that on a larger scale, then we can also sell the data with it. So and of course we put a lot of effort in the data privacy, in the data security, of course, yeah. So, but yeah, that's definitely that's of a big importance, because it doesn't help us if we are efficient as one company, because our mission is to do something of a real impact. So it's also in our interest to sell that data, of course, yeah. Okay, thanks.
I had a question as well. Thank you very much for the presentation. I'm somehow wondering, I see all the state-of-the-art technologies being used, and at the same time you're a company that is trying to sell products. How do you keep this balance of how much work actually is getting done, and how much is the research taking time, and how is it all coming together when you actually have a deadline and need to get things done? So how do you actually make it work?
Depends on whom you ask in the company. Well, of course, for me as part of the research and development team, it's kind of my job. So we have the capacities for doing that stuff, and so we see it as our task to support the other departments. But of course, in like the building system that you have come to know a little bit about, they are quite under pressure at the moment, because building the first buildings is, of course, like it's not all running smooth, of course, yeah. So we have to also do a lot of learning and so. But if I think this is also a function of the scaling up of the company. So as soon as we are moving ahead, and I think we're at good speed now, but as soon as we're getting bigger, then we will have all the capacities for doing all that stuff in parallel. Yeah.
Maybe one question about what you already mentioned with the data security. So how do you do it that you were also talking about using the data and selling it. So how do you make sure that it's not the private people losing their private information?
Yeah. So of course I'm no expert at that topic, but I have had one or other chat with my colleagues in that tech department. So all the hardware that we build into our buildings is kind of double secure, because it's somehow how do you say verschlüsselt, encrypted. So they say it's quite impossible to knock that down, because it's very decentralized. So it's we work with Bluetooth meshes and connecting the hardware on a very local level. So as I said, I'm no expert, but I understand that it's very decentralized and it's not hard to hack. And the data that we collect has already been encrypted. At the moment, it leaves that device. So we can collect data, but we will not know. Well, we can see if it, of course, at the beginning we know where it is and at what area in the building it's been generated, because of course that's if you have some leakage with the windows, also you of course need to know that it's a certain space, but you cannot, for example, see like people moving around, or that information will not be there. So that's something that our compliance department, for example, looks at very strictly. So in the process of collecting the data, it's already been encrypted and decentralized and stored without personal information and so on. So what we can sell is only the technical information, you might say, but not combined with private information.